Hey there, science fans! Today we're diving into the amazing world of DNA. DNA is like a blueprint, a set of instructions that tells our cells how to build and run our bodies. It's what makes you you. Now imagine you have a tiny piece of DNA, but you need more of it to study. That's where PCR comes in. PCR stands for polymerase chain reaction. It's like a DNA photocopier, allowing scientists to make millions of copies of a specific DNA segment. Pretty cool, right? To run a PCR, we need a few key ingredients. 1. DNA template. This is the original piece of DNA we want to copy. 2. Primers. These are short pieces of DNA that act like bookmarks, telling the copier where to start and stop copying. 3. DNA polymerase. This is the star of the show. It's an enzyme that reads the DNA template and adds the matching DNA building blocks to make a copy. And 4. Nucleotides. These are the individual building blocks of DNA, like puzzle pieces that fit together to make a complete DNA strand. With all our ingredients ready, we can start the PCR process. PCR involves repeating a cycle of 3 main steps. First, denaturation. We heat things up. This separates the 2 strands of the DNA double helix, like unzipping a zipper. Next, annealing. We cool it down a bit. This allows the primers to attach to their specific target sequences on the separated DNA strands. And finally, extension. Now it's time for the DNA polymerase to shine. It starts at the primer and adds matching nucleotides one by one, extending the DNA strand. This cycle of heating, cooling, and extending is repeated many times, usually around 30 to 40 cycles. Each cycle doubles the amount of DNA, creating millions of copies. PCR is a powerful tool used in countless applications, diagnosing diseases. PCR can detect tiny amounts of viral or bacterial DNA, helping doctors identify infections early on. Forensic science, identifying criminals or victims from even the smallest DNA samples left at a crime scene. Ancestry testing, tracing your family history and discovering your genetic heritage. PCR is like a scientific superhero, helping us solve mysteries and improve lives every day. And now you know how it works. Keep those science brains buzzing, and I'll see you next time.